Good morning, this is Hallicrafters Rehabs. I'm Albert. This is take 3. It's been a year since I've done videos and I'm a little rusty trying to get things started up again. I've been pretty busy with the shack, getting it going and trying out the transmitter and getting 100 QSO, 1,000 QSOs on the FT8, and then at the beginning of the year I had to focus on my trip to South Asia, which was a lot of planning. I had a number of messages and sermons I had to put together, and that was a blessed time. I just got back, but just before I got back, this AV-680 arrived on the porch after being on order for 11 months. And so now it's time to put it together. And we'll be doing that on the channel. And hopefully it'll be an education for both of us. I did get it opened up. There were a number of staples inside. And it looks like a very solid piece of equipment here, a number of small parts and large parts and some good solid tubing. So I'm looking forward to putting this together, and here's the instructions. And as an engineer, this time I will not be doing step 1, throw away the instructions. Rather than that, we'll be reading and doing the instructions slowly, one task at a time. So I'm going to do this on the channel. I don't know how many videos it will take. There's a number of cables that I'll have to order once I know more precisely what the cable lengths are going to be. And then we'll have to bury some cable. So it'll be a very interesting thing to do. Okay, so we'll start one thing at a time. Okay, this is the base. Step 1 is to assemble the center radiator, which is starting with this base tubing called BA. It's a short piece, and it's attached to the insulator right here, and you use these 1/4 by 20 bolts, which are smooth on one end and machined on the other, and then the nylon self-tightening screws. Put it up there in the camera. The nylon self-tightening screws, but don't tighten it yet. So I have a completed task 1, item 1. Okay, so the next step was to find these counterpoise rings. They actually hold in counterpoise, I don't know what you call them, they're links of aluminum that stretch out, and they attach to the insulator. They attach to the insulator right in here. So you put these together, and inside of that will be these counterpoise aluminum, not even pipes, but stems, and that provides the counterpoise that the antenna operates against when it's assembled, rather than radials on the ground. Well, we got the train coming through right now. But you identify the tubes by their length. I have the measuring tape back there, but this one is a 72-inch length, and it goes on this side of the insulator. And you keep these loose right now, the insulating thing loose. So that will go inside. That will line up the holes which I'm trying to do right now. There we go. Now the holes are lined up. And use the same kind of screws as up here to do the loose fastening right now. Now there are two remaining links of the center radiator. One is slightly smaller in dimension than the other, which is the same dimension as the BB or long piece, first long piece. And it just simply inserts. There's a ridge inside here. It inserts, and then you tighten it down with this hose clamp. This one will go on the top in similar fashion. When I write instructions for engineers, I put the note first and then the step second. Well, these instructions have the note second, and I read that in order, and the note says you can put some Noah locks, which enhances the contact between the two aluminum and reduces the amount of corrosion and so forth, inside this area right here and on the other surfaces as we assemble the center radial. And this is the only place in the antenna where you use this. So I'm going to put that on here right now and reassemble it, which I had it finished again. So it's really hard to hold this camera. I got to get me a GoPro actually. But anyway, so that's what's going on. Okay. Things are getting pretty lengthy here. And what the last piece that went on is the inductor assemblies. And these inductors add length to each of the bandwidths that the antenna will resonate on. And according to the design, each of the band's widths are supposed to be equivalent to 3/8 wave bandwidths, as opposed to a quarter wave or a half wave. They're in between a half wave and a quarter wave. And of course my tuner will do the rest. The specifications will say that the SWR on this thing is less than 2 throughout each of the bands, but with a tuner we'll do better than that. Alright, the center radiator section is complete. And so they have you insert these two tubes together with the one on the left goes in 3 inches, which I was able to measure. And you just use hose clamps. The upper radial or counterpoise or whatever you call them, connection goes right here with just a simple screw and Phillips head. Here's the inductor assemblies. This one was supposed to go in 3 inches. I don't think it's more like, or 4 inches. It turned out to be more like 3 inches. That may create a tuning problem, but that's as far as it would go. And then here's the hose clamp here. And the hose clamp here, going down to the end. Well, as the instruction said, you need to study these diagrams and figure out which ones are aluminum which ones are plastic. These are the stub base and brackets that go up and down for the various lengths of bandwidth vertical antennas, and these will hold those in place. Once you've spent some time studying which part is which, it actually goes together pretty quickly. But you do need to spend that time. So the installation will be basically using careful measurements going up the center radial and installing these brackets. Alright, after putting them in upside down a couple times, this is always on the top side, and the measurement in the directions goes to the top surface. And so the first three are in, the 6 meter, and I believe it's the 17 meter and the 10 and 12 meter bases. And they go in first. They're all metal except this one has a plastic on one side, the opposite side. Okay, so we've got the these insulators and brackets installed, and I'm surprised at how much I've been able to do in half a morning. You have to watch the orientation, of course. Keep checking the diagram, and maybe I have it right. We'll find out when the poles start going in. And you'll make sure it's right side up, the flat part being on the top, and the measurements are consistent, which I give myself maybe about a B on that, maybe a B minus, but I think it will be close enough. So it's lunchtime, so we'll take a break here. Okay, so I forgot to turn on the mic, so I will voice over. The antenna is basically a 9-band J-pole, and all the poles are connected to the center radiator at the bottom, plates for each pole, and the poles easily screw into their respective base brackets. The poles go in fairly easily, but you will have to slightly move the brackets around in order to have each pole line up straight. I have attached the matching box to the pole, which goes in easily with the screws provided, and then attached the bottom radials. The matching unit has a wire that connects the box to the radial bracket, which forms an important ground for the antenna and to work against. Then I attach the mast mount bracket. Later, when I began to mount the antenna to the mast, I found that the mounting bracket U-bolts and the matching box interfered with the mast. I had to reposition everything so that the coax feed went straight out the bottom of the box, and while the mast and the antenna were securely fastened without interference. And then I tightened up everything. The antenna comes with 6-inch, 3/16" diameter solid aluminum couplers, which are supposed to insert inside the antenna stubs and connect the two stubs together with a hose clamp. And then one goes on the end here, and that's not one, by the way. It goes on the end with a hose clamp, and that's what you use to tune the antenna. However, I found 4 that simply would not insert. I inserted one and tried everything under the sun, all kinds of grease, everything else. It was too fat. So I simply went to the hardware store and got these 8mm carriage bolts that did the job to finish off each stub assembly. So the last thing we have to do is install the radials for the capacitance hats, which provides capacitance to also tune the antenna for the 4 longest wavelength bands. So here is the completed antenna. I have the mounting bracket there and the matching box, but that had to be remounted a couple times in order to get the pole in the right position and not interfere with the cable coax. Those are the radials from the bottom of the antenna, which provides the ground that the antenna works against. These are the bottom plates of the additional antenna wavelength stubs that are mounted on the outside of the main radiator. Moving up there, and here's the completed capacitant hats. It's actually this is like, I think it's, well, you're not looking at it right there, but there's a 80, a 40, a 20, and a 15 meter bandwidth, and I think a 30 also. And then the 80 meter there has a large capacitance hat and an inductor with a tap, which you have to decide where you're going to put the tap to tune the antenna. So, and then this top piece, I ended up repositioning it into us to make it more sturdy. And so there's the completed antenna. The next step, of course, is that the antenna has to be mounted on the mast and the mast raised. Okay, I've got it up. But it was impossible to film it holding a camera like this in your one hand and cranking the winch and all this kind of stuff at the same time, and it was not as simple as it looks. I originally had 2 of these poles, and you see that actually up there is the top of the pole, or as you call it, the mast, and there was a small union between the 2, and there was no way I could get that union tight enough in there to keep it from breaking. So paradigms are hard to break, especially when they're your own. I went back and ran the calculations and figured out that, well, it's better off on a 10-foot pole than on a 20-foot pole. In fact, it performs exactly the same, and better at 6 meters when it's on a 10-foot pole. So you see the bracket is different than the way I had it originally arranged. The pole's on one side, the or mast, and the antenna is on the other side. And then there is room, you have to move things around so this happens. There's room for that coax to come down, clear, free and clear. Now I've also got the rope of my end-fed antenna coming through there as well. I was kind of disappointed that I could only use a 10-foot pole because that lowered my end-fed antenna. That's all right. It actually is a one-person job. Now what I do is, originally when I attached the antenna to the mast, I had chairs and a ladder lined up to get a perfect angle to line up the mast with the antenna and slowly worked it together to where it was positioned just where these U brackets had to be installed. So when you're lifting it, cranking up the winch, it will stay quite solid. However, the antenna will flex. It may even startle you a little bit as to how much it flexes, but it doesn't need any support with respect to that flex. It's able to take it, and you just slowly, very slowly, do the cranking on the winch until you have it vertical. Now there's a little bit of a tilt this way because my winch simply doesn't have a bracket in it that properly is squared against the pole. I had to use an angled U-joint to attach the bracket to the pole. So, and then of course this is the hinge that you use, and they're available at a number of hand places. That works very well with this configuration. Now, this right now is just a temporary grounding of the end of the coax. And so this antenna is not ready yet. There's 130 feet, 125 feet of coax that needs to be buried in the ground from here to there. I have a little, garden edger trencher that I'll use to break the sod, and then a square spade should be able to get the job done. But it may take some time and patience. So it's up, but not connected. So with that, I'll say thanks for watching. This is Hallicrafters Rehabs. I'm Albert, and God bless.